Chapter 10, Pythagoras' theorem, no different to Key Stage 3. A whole load of stuff up to grade C was done on the foundation course, and so do click on the link and have a look at that. I'm going to do just one grade C question. This is page 156, question 8, and there it is there. It says calculate the length of the chord AB of the circle. Well, you may recall that a chord is just a line straight through the circle from one end to the other, but it doesn't pass through the centre. Of course, if it passes through the centre, that would be a diameter, and this is not a diameter. That is a chord. Incidentally, just for your information, these must be radii because they go from the centre to the circumference, so we have an isosceles triangle sitting there. Now, you can't do Pythagoras with an isosceles triangle. However, we're given that the height of this triangle from the centre O to the base X is 16 centimetres, and they've even drawn in the right angles for us just so we can make some progress. So we have two right angled triangles, here on the left and there on the right, and since we have a right angled triangle, we have a hypotenuse, the longest side, and 16, the short side. I can work out, let's just call this little baby x. I can work out the baby side x, which is the length ax or a to x, and once I've got to the length x using Pythagoras' theorem, I can then multiply by 2 because this is the same as that. Alright, so once x is sorted, I can just double up my answer and work out the length of that chord. So let's jump straight in. I'm working from left to right. I know that the hypotenuse squared, the big one, so 34 squared, is going to be x squared, the small side squared, plus the other small side squared, which is 16 centimetres, powered up to 2. Again, the two small sides squared make the big one squared. So what I'm looking for is x squared, which is going to be 34 squared, take away the 16 squared. This will work out that a little bit now. So 34, hit the square button. That gives me 1156. Take away 16 squared, that'll be 16 times 16. 256, I should have known that one. Let's subtract to find the square of the hypotenuse, the long length. Leaves us with 900. It's quite a nice number, isn't it? Because when you now press the square root button on the 900, we're going to get 30. I know that one. 30, so x is 30. Just write it in here. I've just calculated it. So this other x here will also be 30. So without any further ado, we can say chord AB is going to be 2 x's, in other words 2 lots of 30, so we're looking at 60 centimetres in total. Alright, and that's like a little starter vid. I'll stop it now, not because I can't get more on, I can get an awful lot more on. I've done a load in the foundation course up to grade C. This is actually still a grade C question. We're still doing Pythagoras in 2 dimensions, up, down, all the rest of it. My next videos will focus solely on grade A 3-dimensional Pythagoras problems. That's the only difference between grade A and the grade C stuff. There is no grade B Pythagoras. One could perhaps call this grade B because it's not just a standard triangle, it's a triangle with back to back with a second triangle to make an isosceles triangle, and that's trapped within a circle. You must have an understanding of the word chord and all the rest of it, so I suppose it's a bit more than a C, but mathematically, in terms of the challenge, it's not grade B at all, it's just grade C. So I'm going to stop there, call that little starter video for you. You've got to look at the foundation videos to secure grade C. Alright, and next time you hear from me, I'll be doing grade A stuff. Thank you.